So hello everybody, welcome to this important series of constraint motion. So we are dealing with the 12th problem in this series, and this is a constraint based problem based on wedge constraint. So over here we need to find the relation between the acceleration of the rod and the wedge, where both the surfaces are free to move. So over here let us begin the problem like this. So if you want to attempt it on your own, you can pause the video and think about a possible solution. So we need to find a possible relation between the acceleration of rod, which is in the downward direction, and the acceleration of the wedge, which is in the rear direction. So we need to determine a relation between these two. So let's get started with the problem. So over here, if I consider that the rod is moving in the downward direction, so over here we can say that after a certain instant of time, the wedge will definitely shift a certain distance, and it will reach somewhere here. So over here we can say that if the wedge slides by a distance x, so if the wedge slides by a distance x, then the rod is going to slide down by a distance y. So rod is going to slide down by a distance y. So over here if we consider this triangle, so over here we can say that this is x because throughout this line the displacement of the wedge is equal to x. So throughout this line this distance is going to be x. And over here we can establish a very simple relation in this triangle, that if this angle is theta, so this one is also theta. So we can write that tan theta is equal to y by x, or y is equal to x tan theta. Now tan theta is certainly not changing whichever direction the wedge moves. So if we differentiate with respect to time, we can say that dy by dt, which is velocity of the rod, dy by dt is velocity of rod, and dx by dt is velocity of wedge. So over here we can say that the velocity of rod is equal to velocity of wedge times tan theta, and similarly it can be on differentiating again, we can say that acceleration of rod is equal to acceleration of wedge tan theta. So this is the final answer for this particular problem which we are looking for, where we are trying to establish a relation between the acceleration of rod and acceleration of wedge. So this was all about the constraint motion series, where we try to solve 12 problems based on constraint motion to understand the concept thoroughly. I hope the series was nice to everybody. Please drop a comment, so that will serve as a feedback for us to make more such contents. Continue to learn, have fun with physics, enjoy watching.